So what we're going to be dealing with now is we're going to be dealing with linear functions. And what linear functions are is basically what we have here is we have this symbol, which is an f. And that symbol, f of x, indicates that we're working with a function. And so the way that that works is this whole idea of linear functions. You've already seen a linear function. It looks like that. Y equals mx plus b. Basically what's happening is when you write in function notation, instead of using the y, you're using this symbol right here, the f of x symbol. And it's written almost exactly the same way as you can see right there. So just to read this off, the symbol f of x is another name for f, or another name for y, and is read as the value of f at x, or as f of x. That's what I prefer. So what is the value of the function f of x is equal to negative 2x minus 7 when x is equal to negative 2? So all we're going to do is we're going to take this value and plug it in right there. So it's the same way as we've done it before. So let's look and see. But one way that we write it out a little bit differently is we say f when it's negative, when the value of x is negative 2 is equal to negative 2 times negative 2, because that's the value of x we're working with, minus 7. So then it's just going to be, this is just going to be 4 minus 7. So it's going to be equal to negative 3. So f of negative 2 is going to be equal to negative 3. That's what we do. And here, same sort of idea. Another function here, f of x, so we're down here now, f of x is equal to 0.3 times x minus 1.2, and we're looking for the value when x is equal to 7. So all we're going to do is, again, plug in the stuff here. So 7 is the value we're looking for, so it's 0.3 times 7 minus 1.2. And when you do that, we're going to end up with this 2.1 minus 1.2. And so that's just going to be equal to 0.9. So the value of f, the value of this right here, of the function when the value of x is 7, is going to be 0.9. And for over here, same sort of idea. Part of the reason why we use f of x is we can use other letters as well, like g and h. If we have several functions that are listed on a graph, sometimes that's easier to see how it works that way. So because you can label them differently as opposed to just saying y a bunch of times. You can say, I'm talking about this particular function. So here, g of x is equal to negative 2/5 times x plus 1/10. And when the value of x is 4. So again, it's going to be g of 4, when x's value is 4, is equal to negative 2 over 5 times 4 plus 1/10. When we do that, it's going to be now g of 4 is going to be equal to negative 8/5 plus 1/10. And so this is going to be negative 16/5, or 16/10, excuse me. Negative 16/10, because I'm just changing it to a common denominator, plus 1/10. So the value is going to be negative 15/10. And when we simplified that, if we wanted to, then it would be negative 1 1/2 is the value when g is 4. So hopefully that all makes sense. It's just plugging in numbers the way we've done it before. So the next thing, though, is it's similar. Again, this whole idea of, in this case here, you're plugging in for the function f of x is equal to negative 3x plus 2. Find the value of x so that f of x is equal to negative 13. By the way, quick question here. What's the y-intercept? Well, it's going to be 2. What's the slope? Negative 3 in this. So that's just a reminder of those, because that's how it works with those. But here, in this case here, we're solving, we already have the number for that. F of x is equal to negative 13. And that says is equal to negative 3x plus 2. So we subtract 2 from both sides. We end up with negative 15 is equal to negative 3x. So x is just going to be equal to 5. Same sort of problem here. It says here, find the value of x so that the function has the given value. So the function's value is going to be 4 is equal to negative 1/2 x minus 3. And so what do? We add 3 to both sides because we're isolating the variable. And so we have 7 is equal to negative 1/2 x. We're going to multiply both sides by negative 2 to get rid of this part here. And when we do that, we're going to end up with negative 14 is equal to x. Over here, now I have h of x. As I said, you can keep going up because if you have a different amount, generally you just go up to h because we'd only show three graphs maybe. But h of x, same sort of idea here. We're solving. It's negative 13 is the h of x value, and now we're trying to figure out what the x value is. So what we do, we add 3 to both sides. Ends up with negative 10 is equal to 5x. So x's value is going to be divide both sides by 5, and you end up with negative 2. So that's how it works. In terms of the next thing, a family of functions is a group of functions with similar characteristics. The most basic linear function in the family of all linear functions is called the parent linear function, which has the following form. This is the most simple thing we got. This is basically, if you were to use the y term, it would be y is equal to x. That means for each time you go up 1 over 1, up 1 over 1. So I'm going to try and draw this right here. So it's here, it's here, it's here. That's what the parent function looks like. The simplest y is equal to x, or in this case here, the function of x is equal to x. So that's what this graph is going to look like, because it's going to be 1, 1, 0, 0, and so on. All these points like that. So now, when we plot these points on there, we'd have a nice, neat line. And when we did that, that would be f of x. Now here, these are going to be a bit different. Graph the function compared to the graph with the value of f of x. So I left f of x up there, so now h of x is equal to x minus 2. So again, I'm going to choose a value of x. So it's going to be when I'm just going to write up here, h of x is 0. The value is going to be negative 2. So 0, negative 2. So it's going to go right there. So when the value of h is 1, the value is going to be 1 minus 2, which is going to be negative 1. So 1 right there. So when the value of h is 2, the value is going to be 2 minus 2, which is going to be 0. So it's going to be 2 over and 0 up or down. So it's going to look like that. We got our 3 points, and so we know we got a right line here. It's going to look like that. So they look very similar, don't they? They just are shifted. They're shifted up 2 because of that value there, that y-intercept value. Now here, slightly different. We're going to leave these up there. Still, now we're going to do g of x. And again, we're going to choose, first of all, when x is equal to 0, what's g equal to? It's going to be equal to 0, 0. So we still have that point right there. However, when the value of x is equal to 1, I'm not going to do that because I want to get rid of that 3 on the bottom. So I'm going to choose the value is 3 for x. Then it's going to be 3 times 1, which is 3 over 3. So this value is going to be 1. So 3 over 1, 2, 3 over, 1 up. It's going to be right there. And now I'm going to choose another point that's easy to graph because of that value 3 there. So it's going to be 6 and 2 because it's going to be 6 times 1 divided by 3 is going to be 2. So 6 over 1, 2, 3, 4, 5, 6, and 2 up. And again, what we got here is we've got a nice line, and that's going to be g of x. I didn't label the other one, so I'll label that now. This is h of x. And if you notice, very important here, the slopes are the same in h of x and f of x. The y-intercepts are the same in g of x and f of x, but the slopes are different. So in this case here, remember here, the value in front of the x is going to be the slope. And if there's nothing listed, then it's assumed to be a slope of 1. So this means, again, each time you go over 1, each time you go over 3, you go up 1. So over 3, up 1, or up 1 over 3, depending upon your perspective. So moving on here, a state park charges $5 per car as an entrance fee. The amount collected is given by the function f of x is equal to 5x. The park recently restructured its fees and now charges $10 per car. The function for the new fee is g of x is equal to 10x. Graph both functions. How is the graph g related to the graph of f? So what's going to happen is we're going to plot these points here. I'm going to bring this down a little bit just to make sure it's clear here. So we're going to remember those two. I'm going to rewrite them. So it's the first one is going to be f of x is equal to 5x. The second one is going to be g of x is equal to 10x. I believe that's correct. Just make sure of that. Yep, great. So now I have to graph these points. And so what I'm going to do is I'm just going to plug in the values. Well, if there's 0 cars, if 0 people show up, both of them are going to be 0 right here. Doesn't matter which one. Both of them are going to be 0 because when the value of 0 is x, then both are going to, then the g value or the f value is going to be 0 as well. So they both start at the same point, but then they move on from there. So now I'm going to plug in here. I'm going to plug in the value 1 for x. So when the value of 1 for x, then g is going to be equal to 10. So actually, just write g of 1 is equal to 10. So 1 over 10 up. So let's put that right there. And then when I have another point here, 2. That's going to be 20. So it's 2 over and 20 up. So it's going to be like about here. And that's going to be one of our lines. That's going to be the second line, actually. But it's going to stop right there because we can't have negative cars. So now we're going to do this other one here. So I'm going to choose a different color to make sure it's not confusing. So for some reason I went with blue with the other one. But when f of x is 0, we already did that one. That's going to be that point right there. When f of x is 1, the value is going to be 5. So 1 over 5 up. Then when f is equal to 2, the value is going to be 10. So 2 over 10 up. And then you can see that's going to go that way. I think I got that pretty reasonably. And then this one's going to keep going that way. So the slope goes up much more rapidly with the value of being the $10 per goes up as twice as steep of a value. So that's kind of the summary of that. So what is function notation? It basically is f of x means the value of f at x, and this is function notation for y. It's just a kind of a fancy way of saying y. Graphs with linear functions can be analyzed and categorized in terms of their relation to the parent function, which is this one here, f of x is equal to x. Function notation is the use of f of x to replace y in functions, and f of x represents the range of the function. Remember, the range is the domain. When we plug in all the values of x we can, that's the domain, and the range is going to be f of x. So that's it. Hopefully that all made sense.